What's up, my pre-calc people? Michael Princhak here. And in this video, we're going to go over the solutions to the polynomial combining with addition multiplication and the polynomial factoring section of the AP Precalculus Prerequisite Skills document that you can access completely for free in the Ultimate Review packet, link in the description below. All right, let's dive right into solving these problems now. All right, adding and subtracting polynomials in standard form should be pretty simple, keeping in mind the big rules here are just combining like terms. So if we're adding these together, we essentially don't need these parentheses anymore because we're just taking this expression and adding it to this expression. So let's see here. So standard form, we just want to make sure we have our highest powers going first. We're going to start off with that x cubed who has no like terms. Then we're going to take that 3x squared, that negative 5x squared, combine those together, and we get negative 2x squared. Take the 2x and the 8x, combine them together, and we get a 10x, and then we have that minus 7 left over. So there we go, nice and simple. All right, we're subtracting. We just have to be very careful that everything after the minus sign needs to take on that negative. So we have 2x cubed minus 4x plus 3 minus 3x cubed plus 2x squared minus 5. So easy to make that mistake. Now we're going to go ahead and combine our like terms. Combining our cubes together, we have negative 1x cubed. Then we have a 2x squared. Then we have a negative 4x. And lastly, we have a 3 and a negative 5 makes negative 2. Nice and easy, not too bad. All right, what about multiplying polynomials and also writing them in standard form? You guys should be pretty trained on multiplying. Just there's a lot of places to make small mistakes here, so be very careful. We're going to go and distribute this 2x. So we get 6x cubed minus 8x squared plus 10x. Easy. All right, when we're multiplying two binomials, we're going to distribute the 3x, then we're going to distribute the negative 6. So distributing the 3x, we get 6x squared plus 15x. Distributing the negative 6, we get negative 12x minus 30. Then we can combine our like terms there in the middle. And you get 6x squared plus 3x minus 30. Pretty simple. All right, now we're going to go ahead and multiply some larger ones together here. So once again, we're just going to distribute the x and then distribute the negative 3 with this binomial times trinomial. So distributing the x, we get 3x cubed plus 2x squared minus 7x. Distribute the negative 3, we get negative 9x squared minus 6x plus 21. Be careful there, two negatives make a positive. All right, going ahead and combining like terms, we have a 3x cubed. We have our x squareds are going to turn into a negative 7x squared, negative 13x when we combine that negative 7x and negative 6x, and finally our positive 21. All right, now here we have a monomial negative 3, a binomial, and another binomial. All different ways you could do this. You can multiply any two of them together first, then multiply. So it's really all how you want to do it. I can go ahead and distribute that negative 3 first and get negative 3x plus 9. Then multiply that by the 2x squared minus 5x. However you want to take a look at that. I can also multiply the two binomials together first, then distribute a negative 3 at the very end. It really is up to you as long as you do all the work correct. So let's see here. I get negative 6x cubed positive 15x squared. Then I get a 18x squared, and finally I get a negative 45x. All right, so I have negative 6x cubed in the middle there. I have a 15 and an 18, and that's going to make 33x squared, and then minus that 45x. Overall, pretty simple when you're working with multiplying, adding, subtracting polynomials. Factoring polynomial expressions is going to be something that really is going to be needed of you, and hopefully you're coming into AP Precalculus knowing how to do this pretty well for the most part. Every teacher has different tricks and stuff like that. I like to just factor, so that's what I'm going to do here. So first we have some difference of squares, which for factoring are probably the easiest for most kids to factor. This is x squared is a perfect square. It's the square root of it is just x. Same with 25. It's going to be 5. It's got to be a difference as well. It doesn't work when there's a plus sign there. So of course we get x minus 5 times x plus 5. And I always tell students, check your work to make sure you're right. And that way you know that you have the factoring correct. All right, here we have a 4x squared and 81. Both are perfect squares, so we get 2x minus 9 and 2x plus 9. Now, the order you put that minus that plus does not matter, but again, double check your work. Now, this next one, most kids are going to say, you can't do it. 7's not a perfect square. Well, you're right. Absolutely right. But I actually want to show you that you can do it because this is going to be something that might come in handy later on in the year as long as you use square roots. So if I do x plus the square root of 7 and x minus the square root of 7, any number technically could be viewed as perfect. I know I shouldn't be saying that if you think about it with square roots. But it does work, right? Because the square root of 7 times negative square root of 7 is going to be just negative 7, so it does work out. It's not pretty, it's not using integers and whole numbers there, but it is pretty and it does work. So don't forget about that strategy as well, but again, it does have to be a minus sign, it does have to be a difference. All right, now let's talk about factoring trinomials. Again, every teacher has different strategies. I like to just think about it and do it and consistently check my work. Might not be the fastest, but I'm pretty good at it, so I think it does work pretty well if you're used to it. So I'm going to go ahead and create my two sets of parentheses here. How do you break down an x squared? Well, the only way to do that is x times x. Then I think about how to break down a 14. And I want to do so, that way my outside and inside terms are going to combine to make that 5 in the middle. So if I think about a 14 and a 1, obviously 14 times 1 is 14, but that can make you a 15 if you add them or 13 if you subtract them. I don't need a 13 or a 15, I need a 5x. But I could do 7 and 2, and a 7 and 2 could definitely make you a 5. So I'm going to put a 7 here and a 2 here. And then it's really just kind of thinking about how I'm going to work this. I want a positive 7x and a negative 2x. That way when I combine them, I get that 5x in the middle. But again, always check your work. It's so worth it. X times x is the x squared. At the end, I have a 7 and negative 2. That's going to make the negative 14. So the outside and that last one check out. Now I'm going to check the middle. That's going to be my 7x and my negative 2x, which make that 5x in the middle. Pretty easy there. That's a really simple one, but make sure you check your work. All right, a lot of kids struggle when all of a sudden we put a number in front of the x squared. Don't panic. Make your two sets of parentheses and say, all right, what's the only way in the world to break apart a 2x squared? Well, it's going to be a 2x and an x. Now I got to think about what I could do to generate the 4 in the back. I could do 2 times 2, I could do 4 times 1. All right, trial and error. Just try something and see if it works. So I'm going to put a 2 here and a 2 here. Now, if I do that, I'm going to get a 4x on the outside. When I multiply these together, I'm going to get a 2x on the inside. A 4x and a 2x can either make you a 6x or a 2x. They're never going to make you a negative 9 in the middle, so that's obviously not going to work, so I got to go back and try something else. Don't panic, just keep trying. Now again, I know there's all different types of ways that teachers could try to trick you to get these answers faster, but I think trial and error is really one of the best ways. So let's put a 1 there and a 4 there. On the outside, that's going to generate an 8x. On the inside, it's going to generate a 1x, and an 8x and a 1x could definitely make a negative 9 if they're both negative. Get my negative 8x, get a negative 1x, that's going to make the negative 9. And then don't forget to double check that you still get that positive 4. And a negative 1 times a negative 4 is, of course, a positive 4. So I get 2x minus 1 times x minus 4. Always check your work. Now, if you know these big X method or all these different methods that teachers teach, that's great. I don't care as long as you get 2x minus 1 times x minus 4. All right, let's try some more. Going to be a little bit more complicated here, but I'm trying to prepare you guys for AP Precalculus, where the factoring might not always be the most basic ones. All right, here once again, the first thing I'm always going to look for is there something common I could factor out. Between 3, 13, and 10, nothing common to factor out. But again, I could break apart 3x squared with 3x and x. How do I break apart 10? First thing that comes to my mind is 5 and a 2. So just do some trial and error. 2 here and a 5 here. Outside's going to be a 15x, inside's going to be a 2x, and I'm thinking, oh my gosh, a 15x and a 2x can definitely make a 13, as long as the 15 is positive and the 2 is negative. So there's my 15x on the outside, negative 2x on the inside, getting that 13x in the middle, and that's going to end with that negative 10 as well, negative 2 times 5. All right, let's try another one here. Let's see here. What's the first way that I think about breaking apart a 15x squared? Well, 3x and 5x, of course. Now, 2 is nice to work with because the only way to multiply to get a 2 is a 2 and a 1. Just got to figure out where they go. So let's go, again, a little bit trial and error. Put the 2 here and the 1 here. That's going to generate 3x on the outside and a 10x on the inside. Well, a 3x and a 10x is not going to make an 11, obviously, so that's not going to work out. So let's try switching those around. We'll put the 1 here and the 2 here. All right, that's going to give us a 6x on the outside and a 5x on the inside. That's definitely going to make a negative 11 as long as they're both negative. Negative 6x, negative 5x makes a negative 11. And then when you multiply the negative 1 and the negative 2, you still get that positive 2. So my final factors here are 3x minus 1 and 5x minus 2. That's a pretty complicated one. Check your work. It always helps. All right, now this one I definitely see there's something common. Now, you don't, in AP Precalculus, you will not have to worry about factoring cubics, okay? So if you are going to give you a cubic, it's going to be something like this where you could factor out an x, making it a quadratic that can be factored. So I'm going to factor out that x. Now I get x squared minus 4x minus 12. And then I'm going to still leave that x. Don't throw it away. Now I'm going to factor that trinomial. X squared is x times x. 12, first thing that pops in my mind is 3 and 4, but a 3 and a 4 are not going to generate a negative 4 in the middle, so let's try 6 and 2. I'm going to make that a negative 6 and a positive 2. That way they multiply to get the negative 12, and when you add that 2x on the outside, negative 6x on the inside, you'll get that negative 4x. There's my total factor. Just don't forget that x out in front there. All right, on this last problem, I'm going to factor out a 3x. It's going to make this problem a lot easier. So I get x squared minus x minus 12. Not too bad there. Double check you did all that right. When you factor out, you're dividing it away. So when you divide that away, you're left with an x squared, a negative x, and a negative 12. But don't throw that 3x away. Make sure you leave it there in front. And then I'm going to go ahead and factor this trinomial. This is actually a pretty easy one. X times x, and the first thing that pops in my mind when I think about negative 12 is 4 and 3, but I do need the 4 to be negative and the 3 to be positive. That way when I combine them, the outside 3x and the inside negative 4x, I get that negative x in the middle, and when you multiply negative 4 and 3, you still get that negative 12. All right, factoring can be tricky for a lot of kids, so again, just practice and always check your work when you're done. That way you can walk away knowing I got it right, or I got to go back and fix something.